Hello, everybody. Hello, everybody. Welcome to the show. My name is Mr. Viteri. Very excited to be here. So, yesterday we were talking about calculating growth rate, and there were a couple things or a couple players that you needed to understand. That was birth rate, how many people being born, death rate, how many people die, immigration, and emigration. And that's how many people are coming into a country or leaving a country. If we're talking about overall population growth, though, we don't necessarily think about immigration or emigration. However, for a particular country, if you want to know what's going on, you would have to calculate those as well. So I need you to memorize this equation. It's down here, and it is on the bottom left. It's growth rate equals birth rate plus immigration rate minus death rate and emigration rate. Now, this can be given to you in a crude form, or it can be given to you in a percent form. Yesterday, we discussed if we took these numbers and now we have this in the crude form. How do we convert this into a percentage? All we have to do is take the decimal over from one spot, move it over here, and now we'll have 12.5% as a growth rate. So I need you to be able to solve problems. Particularly, our test will have a growth rate solving problem. So I'm going to give you the crude numbers. You're going to have to generate it and come up with a percentage. So please make a note of that so you could do well on your exam. Okay. Now that you've calculated growth rate, there's something else that you can do with that. All right. And for the mathematicians in the house, I want you to throw away all of that math logic for a minute and use this simple technique to try to calculate this. This is called doubling time. Okay, doubling time is a known amount of time that it takes for a population to double. So, for instance, if I had 10 individuals in a population, how much time would it take for it to reach 20? So, one doubling time. If I had 20, how long would it take to make 40? If I had 1,000, how long would it take to make 2,000 and then double again and double again and double again? Well, you need to take growth rate you need to solve for growth rate, but in most of these doubling time problems, growth rate is going to be given to you. And to solve doubling time, you use what's called the rule of 70. Say it in your head, rule of 70. You can pause the film here to read through the slide if you need to, but this is another key component to the APES exam and usually involved in either 2 or 3 multiple choice questions and could pop up in a free response question as well. It's good knowledge just to understand what's going to go on to a particular population in general, but it's just a really cool thing to know. So let's dive into figuring out how this works. And for the mathematicians who are like, just think it's like this equation. All right. It's this they just generated this 70 and it works. And of course, it's an estimate of how fast that, and there's certain things that you could take into consideration. But for the most part, it's pretty accurate, or how some people say accurate. Anyhow, so if we take 70, and we take a growth rate of a population that's usually given. And so let's look at this one right here. A population of 1,000 Super Saiyans is growing at 7%. Okay, so this is our population, and this is the growth rate. So I take 70, and I'm going to divide that by, not 7%, I'm actually dividing it by 7, but of course it's the growth rate. And that's going to give me 10 years. So that means that in 10 years, I will have 2,000 Super Saiyans. If the growth rate was stable, then in another 10 years, then I would have 4,000. Another 10 years would have 8,000. Another 10 years, I would have so on and so forth. So even though you're taking the growth rate, which is 7%, you're not really dividing by 7%. You're dividing by 7. And 70 divided by 7 is 10 years. And so that's going to give us that number. Okay? Now, we could play with this a bunch of different ways. I think yesterday we were going over India's population, and India's population roughly right now is like 1.3 billion people. It was growing at a 1% growth rate. If that stays stable, how many years would it take for India's population to double? Well, let's take this. We go 70 divided by 1, it's 70 years. If India's population continues to grow at 1%, then in 70 years, in one lifetime, that population can double. It's it gets kind of scary when you have a high number of 1%. Think of Uganda, which had 3.6, or let's just make that simpler. 70 divided by 3.5, I believe, is 20 years. In 20 years, Uganda's population could actually double. Oh my God! In 40 years, it could actually. Wow. So you could see how a human population can grow exponentially. Going back to what we want zero. So the number of people living and dying are equal to the number of people being born. Actually, that sounds pretty bad, but I think you understand what I'm trying to talk about, reaching carrying capacity so we don't exceed our limiting factors. All right. Okay, pause this, read it, try to think of it through, try to see if you could solve that first problem. Now, that second problem, how many years will it take for the Saiyans to reach 16,000 if the growth rate is the same for all those years? Well, if we started with 1,000, here's the camera. It will take 10 years to get 2,000, another 10 years to get 4,000, 8,000, 16,000. I don't know how many jumps that was. I'm going to do it on paper, and I'll show you what it looks like on paper. So we got 1,000 doubling to 2,000, doubling to 4,000, doubling to 8,000, doubling to 16,000. So this is what it would look like as we jump. Now, if I count how many hoops we are, 1, 2, 3, 4, there are 10 years for each jump. So to answer this question, it'll take 40 years, 40 years to reach a population of 16,000 Super Saiyans. All right. Wait, 3.5. Yes, 3.5 was 20 years. Okay, so now let's look at that final problem. Growth rate is 2%. How many years will it take to double? So we'll take 70 divided by 2. That's 35 years. In 35 years, the population could double with any population that has something like that. This means this is significant. Okay, you could look at the growth rates for each individual country now and figure out, well, what could possibly happen if something doesn't happen to the growth rate. And once again, as countries develop, from developing to develop, that growth rate tends to decrease. Now, and we also talked about yesterday that developed countries sometimes actually go into the negative numbers. And we gave examples like Japan, and we gave numbers like Italy. Okay. Growth rate is a very important topic, especially when we're talking about environmental science. All right, let's continue. All right, so we're looking at some accurate data, and this was probably made 2 years ago, so it's probably not as accurate. But it's important to understand that the world population is roughly like 7.7 billion. Granted, when you make an APES exam, you're taking data from approximately 3 years before. So anywhere from 7.5 to 7.8 is a logical answer for what is the total world population. Okay, there's never going to be a choice between 7.7.8 or 7.8 billion and 7.7. It would be too close, right? It really depends on the particular time. So just have an understanding of what their population is. Understand that China is still the number one country in the world in regards to population. India, the second. United States is going to be the third. And in this particular region, I think knowing the top three would be important. More importantly, understand the growth rate. Understand the relevance of how big China is into India versus the rest of the world. Okay. And so here is something that's really, really important. All right. Interesting fact over here as well. We'll look at some life expectancy. And when you're talking about world population, that's different too. So world life expectancy is going to be 72. China's life expectancy 77. India's life expectancy 69. United States, we got an 80. Indonesia 70. Brazil 76. Some food for thought right there. All right, let's continue. So with these projections, we could actually figure out what's going to happen in the future. So Uganda was an outlier yesterday when we looked at their growth rate. I think it was 3.6 as of 2019. So what does that mean in the future? Well, that basically means that you're going to need to have a lot of food in the future to support and feed all those people, because young people make more people, and so on and so forth. And so you either better develop to get that food, or there's going to be war, there's going to be conflict, there's going to be competition for limiting factors. So that is an issue. All right. You can project how many new people are going to be added to the population. I know this was difficult yesterday, and I want to take a second to try to figure this out. Okay. I was asking the mathematicians to do this. Let's try to do it easily. So let's say the population was 100. Okay. And let's just say the growth rate was 1%. Well, how can I do this in a calculator to basically see how many individuals are going to be added to the population? Okay, so all we have to do, since it's 1%, we have to take 1%, make it into a whole number, which basically means you have to divide it by 100. Which basically means what you have to do is you have to move the decimal over to the left 2 times. Pay attention. Move the decimal over to the left 2 times. Okay, so if we took that 1% and we moved the decimal 1, 2, it's actually 0.01. So what I have to do in a calculator is basically take 100 times 0.01, and that's going to give me 1, which is 1% of 100. Does that make sense? Okay. All right. And you know what? Pause this, get your calculators out, and try to understand that, because I'm going to throw you for a loop. Now, if China's population is 1.5 billion, first of all, you need to understand how many zeros is a billion. If you don't, do it. Do it in your head, write it down, and try to count all those zeros. Now, if it's growing at 0.4%, now how do I convert that into a whole number? I still just have to move the decimal over 2 times. So if I was going to see how many new people are going to be added to China's population, what I have to do is take 1.5 billion and multiply that to 0.004. And that's going to give me a number that's going to be equivalent to 0.4%. Okay, so divide the percentage by 100, gives it a whole number, and then multiply that to the number so you can see how many new individuals are going to be born. And so you could project what's going to happen to the population. Japan is going to deal with issues regarding repopulation. So what can you do as a country to try to change the scenario? Because you need workers. You need workers for tax purposes. You need workers for the military. You need workers for running the country, growing food. Okay, basically doing stuff like that. Because once people start to get to retirement age, that work still needs to be done. And so knowing growth rates, populations, life expectancies, a country can plan on future plans. All right. And yesterday we were talking about government programs to increase the fecundity. I love that word, fecundity. And there are other programs that we can use to try to limit population growth. All right. But there's a nice term here, population momentum. Going back to Uganda with 3.6, what does that mean? There's a lot of population. As a population starts to grow, it leads to growing and growing and growing. All right. So that's that term, population momentum. Okay. Now, yesterday we talked in detail about the China's one-child policy that was abolished in 2015, but in 1979 it was enacted. And so it led to a series of consequences, one being a skewed sex ratio. All right. That's a vocabulary word, sex ratio. That basically means how many boys to how many girls, or how many girls to how many boys. Now, does this matter in a society? Well, it kind of matters. And in China, I believe there's a slight skewed ratio, more males than females. And I know in other places like the United Emirates of Arab Emirates, there's a very skewed ratio where there's a lot more males there's like maybe like 6 males to every 1 female in that particular country. Now, how does that result? Okay, well, first of all, why is it a problem? Well, sometimes remember how we were talking about limiting factors and the ability to find mates. If there's more of one sex, then the ability to find mates would become a problem. All right, so that's number one. And if the ability to find mates is a problem, then you're not securing the next generation or the likelihood of a more populous people coming out. Now, that means less workforce. And if you have less workforce, you have less people paying taxes to pay for the older people who are in retirement. And so this is why a population probably wants to become stable, not shrinking or not growing at the same time. And so 2015, they implemented a two-child policy. Okay. I think I lost my train of thought there, but just understand that we want stable growth. This shape doesn't mean anything. It'll mean something in a second. All right. Now, we've been talking a lot about developed and developing countries. Okay. And this is a very famous model. It's called the demographic transition model. Say that in your head. Demographic transition model. Very, very good. Okay. And this is basically a model that every country goes through in its development process. There are 3 players here. Okay. You have your birth rate, which is this top line here, your death rate, which is this black line underneath it, and then you have your total population. And so this really corresponds with what are the people really doing? Okay. What is the country really doing at that particular time? All right. Now, and typically there's a 4-stage model, and that's probably the one that's going to be on the AP exam. There is a 5-stage model. Just understand how to read both. It's fine. If we're trying to talk on an AP exam, they should give you the proper model. That's the one that you're talking about. All right. So in general terms, we talk about a 4-stage model, but we're going to talk about the 4-stage model, and that leaves this 5-stage off. But I like entertaining the idea of the 5th stage. So let's look at what's going on here. Birth rate, death rate, and total population. And it's giving us examples what type of countries are dealing with this right now. And it doesn't even say a country. Okay, so I want you to think of like this is a few remote groups. This would be like living a nomadic life. This would be like living in a tribe in Peru. I believe there's some people that still live cut away from civilization, if you will, or technology, if you will, that kind of live at their own tribes in the jungle, which is so fascinating to me. And they're pretty much totally independent of any type of technology, fossil fuels, or anything. So they hunt for their food, they gather their food, they take care of their own. It's a crazy. To me, I don't think I'd last 2 days outside, but these people basically are living outside. It's amazing. Okay. But doing that is tough, living outside, especially I could just only imagine with an infant. And so if we're looking at birth rate, people are reproducing like bunnies. However, unfortunately, since they're outside, there's animals, there's diseases, there's sickness, there's poison ivy, there's so many things. So the death rate stays high. So if birth rate is high, that typically says that the population is going to grow. However, if death rate is high, a lot of people do die, then the population stays relatively low. So this would be stage 1. Okay. And this would be what's considered the pre-industrial stage. Let's try to understand that and think of that. Pre-industrial. All right. Then we have stage 2, and we got some examples of Egypt, Kenya, and India. This is kind of outdated, but you'll get what I'm explaining here. We call this the transitional phase. Okay, this is a transitional phase because now it's transitioning. All right, and here what we notice is that people are still reproducing like bunnies, but the death rate starts to fall. If the death rate starts to fall and people are reproducing like bunnies, all of a sudden the population starts to increase. Okay, population starts to increase. Okay, so what would cause the death rate to start to decrease? Well, what happens is there's developments in meds, there's development in sanitation, there's development in food. And so this causes the death rate to basically slow down, but people are still having a lot of babies because they're probably working the farm for the reason. So they need a lot of workforce. Okay, let's go to stage 3, and stage 3 would be now the farm life is kind of slowing down. Technology is becoming less and less. So now we're transitional. Now we're in the industrial stage. Okay, and what's happening is that people don't necessarily have a need to have that many children. So what happens is the birth rate starts to fall. Okay, but as long as the birth rate is higher than the death rate, the population continues to increase. But notice the rate of increase is actually slowing down now. Okay, examples would be like Brazil. So once again, this is going to be the industrial stage. All right, so we'll call this pre-industrial, transitional, industrial, and this is going to be the post-industrial. So now here, eventually we get to the birth rate equaling the death rate. So like we said in class yesterday, people most likely, a family planning size is about 2, and when grandma and grandpa dies, that's basically going to become equal. When that happens, our population stabilizes. Some examples of countries would be USA, Japan, and France. Well, this is an old model, and this is why I like to use step 5. So step 5 actually shows that the population is decreasing. And what happens is when the birth rate actually shrinks below the death rate. And so Germany was in that situation. Japan is in that situation now. And so this would be like, remember when a couple of the students in our class were like, nah, I don't really think I want to have kids. I'm going to enjoy my own life. Well, if the majority of the population begins to think like that, the total world population could start to decline in that region. All right. Some people feel that the world population should decline to get to a new carrying capacity so we can basically live sustainably into society. I can't tell you what to basically family plan. I just love my baby so much. All right. So let's keep going. That is called the demographic transition. Please understand the demographic transition. It's a very, very important thing. All right. Stage 1, stage 2, stage 3, stage 4. Understand what's happening. Okay, understand that this pre-industrial, there's a transitional, there's the industrial, and then there's the post-industrial. We basically slow down. All right, and I guess we could call this the post-industrial. Okay, we're like super advanced at this point. All right, and know some examples of what's going on in this region. All right, like know a country. All right, okay. So a couple of other things that are pretty interesting to note when you're looking at population sizes is the infant mortality rate, okay, or life expectancy. We talked about life expectancy, and in developed countries, and I believe the United States, it was something like, I think 82, and China was 77, and I think Indonesia was 69 or something like that. So developed countries tend to have more of a life expectancy. We can correlate that with basically cleaner water, cleaner air, all right, cleaner resources, all right. We also tend to have lower infant mortality. Now, what is that? What does that mean? That basically means the death of an infant. And so these numbers here on this graph would be infant deaths per 1,000 live births. Okay, so out of 1,000 people who have a baby, how many babies die at birth? And so you can gauge, I guess, how developed a country is. Depending on the infant mortality rate. You would have typically higher infant mortality if you were in stage 1 of the demographic transition, because, oh my gosh, what if an alligator's chasing you, and you're pregnant or you're giving birth? You really can't do that. But anyhow, in this image here, this is actually wealthy nations and their infant mortality. Surprisingly, the United States isn't the top one. Finland would be the lowest infant mortality, 2.3. There's a number of countries that are actually above us. And then the United States are at 6.1. Okay. So infant mortality rate, that's another vocabulary word. Make sure you understand that. All right. And so here on the opposite side of the spectrum, so we will talk about more developing countries or countries that are developing, really sad. We'll look at Madagascar, 106 child deaths. All right, which is pretty sad. That's almost 10%. And then I think over here, Burkina Faso, which I don't know where it is, but 190. So that's almost closer to 20% of the babies that are dying. So infant mortality is something that needs to be, I think it coincides with the development process. So as medical advancements continue, as hospitals get born, as people start wearing gloves, what happens is infant mortality goes down. As more resources that we can feed babies, those babies are more likely to survive. All right. Okay. And then we looked at life expectancy, and we talked about the developed countries typically live longer. All right. Another thing that we need to talk about is total fertility. All right. Total fertility. All right. And when we're looking at total fertility, that means, well, how many babies are we going to relatively have? And over here, we have, I believe, the highest fertility rates, a country called Niger, 7.1, Chad, 6.7. So this is the family size. All right. This is the family size. Somalia, 6.1. Congo, we talked about Uganda with the growth rate, 5.2. Okay. And then we could look at other countries. India, 2.1. What do they have? Like 2 kids and a little kid? It's a number. It's an average. In the United States, it's actually at 1.8 right now. Okay. So that means they have 1 kid and like 80% of another. I'm just kidding. It's a number. All right. So this is another thing that can correlate with basically growth rate. So let's figure out how many babies each country is particularly having. All right. China's having 1.5 at this point. United States 1.8. India's having 2.1. All right. And Japan and Singapore 1.3. So their populations would probably be in decline. And I believe Germany. I remember Germany almost got me, man. They were recruiting for people to emigrate over there, because they were like free college, free school, free medical, and I was like, man, it might be nice to live in Germany, but it's a hard language to learn. So understand that as the fertility rates slow down in a country and they see that their workforce is basically dwindling, then immigration policies typically change as well. All right. Okay, so how can we lower the total fertility rate? And I believe this would probably be a picture of Niger or Congo, and this is the United States. Okay, and this is Eddie Murphy, one of my favorite actors here. One of the biggest things that you can do to control population growth is educate women. Now, what does that mean? In certain countries, women don't have the opportunity to work and become a provider. And so when that happens, the main goal for a woman it would be to start a family. And so remember yesterday we were talking about that window of reproduction. So I think one of our students said that they were going to start having their family perhaps at 26 or 27. Well, what does she necessarily had to plan in order to do that? She was planning on going to college, at least with a 4-year, then get a grad work on top of that, and so on and so forth. And now she's probably going to be engaged for 2 years. It brings her to 26, and then the window probably closes roughly around 45. And so that gives her about a 20-year window. Well, if you opened your window at 15, then you're 15 to 45. I can't do that math. I think it's something like 30, but that would be a significantly larger window where you would stay fertile, which would basically increase the overall family size. All right. So the education of women is very, very important. When we talked about medical advancements, stuff like birth control and family planning, these things also tend to shrink a population as opposed to allowing it to grow uncontrollably. All right. Okay. All right. We're going to end that, and I hope you appreciated that and liked our lecture for today. All right. Bye.